Hello everyone, today I will discuss TSK Fuzzy Model, that is Takagi Sojino Kang model. Earlier I already discussed Mamdani and Larsen Fuzzy Model. So same concept will be applicable. There is a little bit difference. The TSK Fuzzy model was introduced by Takagi, Sugino and Kang in 1985. Right. So the applicable typical fuzzy rule in TSK fuzzy model: if x is ai and or both these operations can be performed, y is bi, then z is equal to fxy. Right. Earlier it was z is equal to ci, but in this case it is a function. So the function is represented by this one: p naught plus p1x plus p2x square plus and so on, q1y plus q2y and so on. So where a and b are the fuzzy sets in the antecedent, where z is equal to fxy is a crisp function in the consequent. And one more important, TSK fuzzy model takes comparatively less computation time with respect to Mamdani and Larsen fuzzy model. Usually fxy is polynomial, right? And one important thing we have to take care, TSK fuzzy model takes only crisp value as input, but earlier both the model Mamdani and Larsen will take crisp as well as fuzzy values as input, but in this case only crisp value will be given to the model. So each rule has a crisp output. If there are 20 rules, then there will be 20 crisp output. The overall output is obtained via weighted average, therefore is avoiding the time consuming process of defuzzification required in Mamdani and model. So in this case there is no requirement of defuzzification, so we will calculate weighted average, right? So when function this is constant, then it will be of zero order TSK fuzzy model. When order will be higher, first order, second order, complexity will be higher and computational time will be large. So when fxy is a first order polynomial, the resulting fuzzy inference system is called first order TSK fuzzy model, right? And zero order TSK fuzzy model is a special case of Mamdani fuzzy model, right? So there is another one model also available, but I will not cover this fuzzy model because it is not so much important from final exam point of view. So this is the TSK fuzzy model, and this is the rule where we find out the depth of firing. We have to take the minimum of them, and this is the aggregated output. So in this output will be crisp, so no defuzzification is required, right? So we will continue with example. First of all, we will discuss zero order TSK fuzzy model. This is the function equation fxy of a polynomial degree m with respect to x and with respect to y, right? So in zero order, all these terms will be obsolete. All these terms will be obsolete. Only there will be a constant value which is equal to p naught, right? So we will calculate now. There will be same three type of explanation will be there: single rule with single antecedent, right? And single rule with multiple antecedent, multiple rule with multiple antecedent. So zero order with TSK fuzzy model, single rule, single antecedent. So there is only one rule, that's why it is single rule. If x is a, then y is equal to this. So there is only one rule and there is only one antecedent, so that's why it is a single antecedent. If x is a, then y. This is the function, but because it is of zero order, therefore this will be equal to p naught, and p naught is a constant. Now we want to calculate the output when input is equal to x is equal to x1. Then what will be output, right? Now I want to calculate that when input is given to us, that is if x1 is 2.0202, then what will be output. So when I superimpose with given fuzzy input with given function, so it will intersect at this particular point, and this is the degree of compatibility, right? So degree of compatibility, because there is only single rule, that's why this value of w1 will be equal to 0.52 as it is. This value will be reflected here, and value of p naught, which is a constant value, which is a constant value, will be reflected as y1 is equal to 3.73. Now we want to calculate the aggregated output, that is y star, and this will be equal to w1 multiply y1 upon w1. So w1 cancel w1, and finally it will be equal to y1, and value of y1 is equal to 3.737. So this is the case with single rule and with single antecedent. Now single rule with multiple antecedent. In this case, if x is a, first antecedent, and at the place of and it can be or, and y is b, another antecedent. Therefore it is the case of multiple antecedent, and there is only single rule, that's why it is known as single rule. And in this case, of course it is of zero order, that's why we are considering it as a zero order, and the value p naught is known to us. Now we want to calculate output when x is equal to x1 and y is equal to y1. For this case, what will be our output? So let us take with the example. If x1 is equal to 4.444 and y1 is this. This is the input for which I want to calculate my output. So when I this input intersect at this particular point, and this is the degree of, this is the point of degree of compatibility, and this input y1 is intersecting at this particular point, and this is another point, degree of compatibility. Now what we have to consider, out of this 0.1868 and 0.8924, we have to take the minimum value, and minimum value is equal to 0.1868, right? So this is the w1, because we already know this is the constant value and which is known to us. This will be treated as our z1, because it is having the multiple uh, antecedent, that's why a new term came into existence, z1. In earlier it is x and y, that's why it is represented by y1. So y1 will be replaced as y1 will be replaced by z1. Again we have to find out the aggregated output, w1 multiply by z1 and w1, again w1 cancel out w1, so final output will be z1, means whatever be the constant value, that will be our final crisp output. Now we are going with the multiple rule with multiple antecedent, rule 1, and this is rule 2. That's why it is known as multiple rule. Multiple antecedent because x is a1, one antecedent, and y is b1, another antecedent. That's why it is known as the multiple antecedent. So in this case output is equal to this one. In this rule output is equal to this one. Now I want to calculate the output for input when x is equal to x1 and y is equal to y1. Then what will be my output? So conclusion, z will be equal to w1 multiply by p naught 1 for rule 1 plus w2 multiply with constant value for rule 2, because it is of zero order, that's why they will be constant, and divided by W1 plus W2, that is depth of firing, right? So let us take and with the help of example, this is the rule 1, this is the rule 2, and if this, and we want to calculate the output for this crisp input, right? So x1 intersect at this point, and degree of compatibility is equal to 0.93, and in this case y intersect at this particular point and degree of compatibility is equal to 0.78. So minimum value between 0.93 and 0.78 is equal to 0.78. So this is the W1, and P note 1 represent the for first rule, and 0 represent the for zero order. So P note 1 is equal to 8. So therefore this will be equal to our value variable Z1 is equal to 8. For second rule, what we have to consider, so x1 intersecting at this particular point and degree of compatibility is equal to 0.99. In this case, this intersecting at this particular point and degree of compatibility is equal to 0.13. So out of 0.99 and 0.13, we have to consider the minimum value, and the minimum value in this case is equal to 0.13. Therefore this is the depth of firing. So again Z2 is equal to 6, because P note 2, this is known to us and this is represented by Z2. So we have the value of W1, W2, Z1, Z2. So the apply into the particular formula. So W1 into Z1 plus W2 into Z2, and after final calculation the output will be equal to 7.7143. So in this way we can calculate the TSK Fuzzy model, and in this there is a no defuzzification process occur. So overall with the help of this we can calculate our crisp output. That's why it take less time with respect to Mamdani and Fuzzy model. Now if we look at the first order TSK Fuzzy model, then how it will be applicable. For first order, P note will be considered in the output, and P1x, this is also the part of model. This it is of higher order, second order, so all will be obsoleted. Again Q1y will be also part of this, and rest of the higher part will be excluded. So finally for first order equation will be like this: fxy is equal to p naught plus p1x plus p2y. P naught, p1 and p2 are the constant. So again we have to use single rule with single antecedent, single rule with multiple antecedent, and multiple rule with multiple antecedents. So these are the equation which I already discussed, and same process will be there. So without wasting time I will go ahead with the single rule. So if x is a, there is a single rule and there is only single antecedent, and if x is a, then y is equal to this one, but it is of first order, then now this is will be equal to p naught plus p1x. Now I want to calculate at the output, at the input x is equal to x1, so output will be equal to this one. Now with help of the example, so I want to calculate output for this particular crisp input, and now degree of compatibility is equal to 0.5204, same in the last example, but in this case our value y is equal to 1 plus 0.5x. So as it is, this will be our value of w1, and if x1 is equal to this one, x1 is known to us, and what will be the value of y1? So y1 will equal to 1 plus, as it is, 0.5 and x. So we will put value of x in this particular, and the output will be equal to 2.01101. So again apply the formula w1 into y1 divided by w1, w1 cancel out w1, so therefore it will equal to 2.0101. In the same fashion single rule, but in this case multiple consequent. X is A, Y is B, therefore multiple consequents. Now output, the output will be is equal to this one, P0 plus P1x plus P2y. So I want to calculate my output when x is equal to x1 and when y is equal to y1. So this will be applicable. So now when x is equal to 4.4, degree of compatibility equal to this one. When y is equal to this one, degree of compatibility is equal to this one. So out of these two values, we have to consider the minimum value, and minimum value is equal to 0.1868. So this is our W1. But this is the value which is known to us, 0.1, 0.5x plus 0.2y. So we will put value of x1 and y1 in this particular equation, and after solving that, we will get z1 is equal to 3.5747. So again apply the same rule, w1 into z1, so w1 cancel out w1, so final value will equal to z1. So value of z1 is equal to 3.5747, right? In the same way, multiple rule with multiple antecedent, rule 1, and this is rule 2. Fact. And now I want to calculate output when x is equal to x1 and when y is equal to y1. So same procedure will be followed. So nothing so complex. So right now for rule 1, when x is equal to 6.1, right? So degree of compatibility 0.93. Now when y is equal to 0.82, degree of compatibility 0.78, right? And right now we have to consider the minimum of them, and minimum is equal to 0.78, and this is the z1 which is known to us, and we have to put value of x1 is equal to 6, uh, value of x is equal to 6 and y is equal to 8.2, because for this input I want to calculate my output. So put this value in this equation, and it comes out to be z1 is equal to 4.74, right? In the same fashion, when x is equal to 6, so in the second rule, degree of compatibility 0.99, in this case degree of compatibility 0.13. So we have to consider minimum of them, and it is equal to 0.13. Again same equation, this is the equation in which we have to apply x1 is equal to 6, in which x1 is equal to 6 and y is equal to 8.2. So after solving this, the value of z2 is equal to, that is 2.34. So we already know w1 z1, w2 z2, applying this particular formula, and finally crisp output is 4.3971. So in this way we can calculate our TSK Fuzzy model for zero order and for first order and second order and so on. If the order will be high, then complexity will be high, and definitely more precise result will be available. So this is the first example how it would look like, and this is the question is being asked in assignment 12. So rule 1, rule 2, rule 3 and rule 4. There are 4 rules. If x is low or y is high, then output is equal to this. So this is known to us. Same which is being asked in assignment 12, right? So TSK model will be more appropriately which will be asked in final examination. So A is equal to it is being asked in assignment 12. So now the membership function input A and B, actually in our final examination this function will not be available with us. Most probably triangular function will be available so that we can easily draw, because in that there are difficulty to draw, and to find out the exact value it is impossible to calculate. Now what is our target? We want to calculate output Z for the input x is equal to 70 or y is equal to 60, and universe of discourse for x and y is equal to 0 to 100. So we have to draw first this membership function, whether it is triangular, trapezoidal or Gaussian. For this, now I want to calculate the output for input x is equal to 70 and y is equal to 60. So in this case, degree of compatibility for this point 0022, and in this case 1, and here it is 1. So applying all these where it intersect, so we have to apply all these particular rules where it is intersecting. So we have to calculate max mean values in this way. So it is a little bit complicated, but in final examination it will not be asked because due to more complexity. So finally there are 4 rules and only 2 rules are applicable, rule 1 and rule 4. So for these 2 rules, what will be the output? This is the output. Again we have to put the value of x and y. X is equal to 70 and y is equal to 60. We will calculate value of Z1 and Z2, Z1 and Z2 in this way, right? And degree of compatibility, from the degree of compatibility we will find out our depth of firing. So minimum value is 0.0022, or but in this case it is considered maximum. Instead of mean, we are going to take the maximum value because minimum value is 0.0022. So max mean, minimum or maximum, we can consider as per the requirement, whether it is based upon the question we want to calculate minimum value or maximum value, right? So in this case maximum value, here it is 1.0, here it is 1.0. So again maximum value is equal to 1. Apply into the particular formula and final answer will be equal to Z2 is equal to 8.8. Now we have to aggregate. So W1 is known to us, Z1 known to us, W2 is 1, again Z2 is known to us. Apply these values in this particular formula, and finally Z is equal to, Z star will be equal to 25.4. So in this way we can calculate. In the same way we will execute second example for first order. I think so it is sufficient for our final exam point of view. So thank you so much.